Hey everyone, welcome to the channel. This is a new playlist on sorting. In this playlist, we are going to cover a lot of topics related to sorting. We will start with introduction to sorting, which is very basic introduction and discussion on what sorting is. After that, we are going to dive into various sorting algorithms. We are going to do their analysis, and finally we will look how their code look like. To start with, we are going to do the sorting code on Java, and with time we are going to add more code in other languages, which could be C++ or C sharp. So let's start with introduction to sorting. So what sorting is? Sorting is basically arranging your data in a very specific order. Generally, this order is either in increasing order or decreasing order. By increasing order, we mean that our data is going to be in the form of increasing values based on a certain rule. Now, the rule could be, if we talk about integers, the integers will grow from lower values to higher values. But the sorting of data is not necessarily on only integers. It could be anything based on a certain rule. So let's take an example which is like very basic. Let's say we have an array of numbers, and we want to sort it in increasing order. So when we talk about increasing order, the values are going from lower values to higher values, and our final array after sorting in increasing order is going to look like this. Similarly, if we want to sort the same array in decreasing order, it would look like this, right? So this is like basic sorting of an integer list. This could be anything else. For example, if we have an array of string, so let's say our array of string maybe looks like right. Now, if we want to sort this array of strings in increasing order based on dictionary search, this would probably look like this. Sorry. So probably my initial list was already sorted, right? Okay. There are a few terms which I feel we should know before we get into more detailed sorting topics. So the first one is in place. In place sorting means we are going to sort the data in the same storage and we are not going to use any extra storage. Which means if we look at this array of integers, we are going to sort this array of integers in the same storage and not going to use any other storage. Okay. Now the opposite of this is taking extra memory, which means use extra storage memory. For example, let's say we want to sort this. We take an extra memory. And let's say what our sorting algorithm does is takes out the minimum value from this array and copies that into the extra memory. So the minimum value is 1, which is copied in the new memory, and this is deleted from here. After that, we see that 2 is the second smallest value that is copied here, deleted from the original source. And after that, 3 is deleted from here, copied here. So you see that we did a sorting, but we used extra memory instead of using the original memory. So this is called extra memory, or we are not sorting in place. Then the third one is stable sorting. This means that the relative order of same values are going to remain same after the sorting is complete. Relative order of values are retained. This means, let's say we again have an array and which has two values which are same. So this is the first numeric 2 and this is the second numeric 2. When we do a sorting and let's say we are using extra memory, so this should go here, this should go here, and this should go here. So the first 2 is always before the second 2, and we are retaining the original order of same values, and this is called stable sorting. Now similarly, let's say we have an algorithm and which sorts, but it does not retain the original order. So it, after sorting, this 2 goes here, this 2 goes here, and then this 3 goes here. So second 2 came before the first 2, and the original order of same values is not same, and this is not stable. Okay, I hope you are able to follow my explanation on stable sorting. After that, we have swaps. This means when we change the index of any value, we are doing a swap. So let's say, and we want to sort the value in the same array. So for the first iteration, let's say what we do is we do this. So what we did is we swapped 2 and 3. After that, let's say we swapped 1 and 3, and let's say after that we swapped 1 and 2 to get the final sorting order. So how many swaps we did? 1 swap here, 2 and 3. So if you have a problem which asks you to find out how many swaps that algorithm is going to do, this is your answer. Okay. After that, there is another term, comparisons. This is when we check or compare two numbers to find out which one is greater or which one is smaller. That is called comparisons. So let's say you have an array and you want to compare these two values, and if the first value is bigger than the second value, you are going to swap. So this means this step did a comparison plus a, right? But it is not necessary that it will do a swap. For example, if we take another example where I have this, it did a comparison to check if the first number is greater than the second number, but the first number is actually smaller than the second number. So there is not going to be any swapping done, but we actually still did a comparison. But no. So this is all about a very basic introduction about sorting. I am going to see you in our next lecture on sorting, which is going to be insertion sorting. I'm going to end this session here, and I'm going to see you in our next session on insertion sorting. Thanks for watching, and bye for now.